One in. Can we continue? Yes, sorry about that. Because they just called me to join that their Dr. No resign in July. So I'm with them at the third floor now since 16 June actually. I joined the TD office in charge of the industry and community engagement, replacing Dr. Lim Sok Fong. So not many people here, so I have to join them for a while. So done. So you can continue the lecture now. Okay. So just now we just look into the overview of control system design, where we look into 5 issues which is important that need to be considered by any control system designer. Yeah. With regards to safety, environmental regulations, product specifications, and production rate. And also with regards to economic plant operations and as well as the stable plant operations. Yeah? So the number five, for example, is very much on what you are learning now in this course, instrumentations and control, especially on the control part. Yeah, with regards to stable plant operation. Yeah. Whereas the first 4 issue, safety, environmental regulations, community, and number 3, with regards to money issue, profitability of the plants, money issue. Yeah, same goes to number 4. But number 5 is actually what actually we have learned in the past, and say in the past 4 or 5 weeks when we studied control systems. Yeah? So let us look into the operator's view of process control. Yeah, if you um, have the opportunity to visit a plant, yeah, to be a manufacturing plant or even a power plant like Batang Air hydroelectric power plant or Bakun power plant, for example. I think you already visited Bakun 1 or 2 years ago, did you? I still have that photo of um, Dr. Daniel brought um, 3 or 2 lot of Unimas bus visiting Bakun power plant, yeah? Hydroelectric power plant. Yeah? So if you visited that kind of plant, yeah, be it manufacturing or even power plant, if you visited the control room, yeah, you will see picture like this, yeah, where an operator, or in case of a big plant, maybe an engineer, yeah, in charge of the control room will sit and look at the monitor. Yeah, it's a computer monitor, such as what you can see in the picture here. Yeah, there are probably as many as 6 or even more monitor in front of him. For a small plant, probably one is 1 or 2 monitor probably suffice enough. Yeah? But for a big plant, probably they're talking about 6, 10, or even 20. Yeah? So from there, they can see the diagram, as you can see in the picture there. Yeah. And this picture actually very much showing the real-time actions, the equipments that monitor the processes inside the plant. Yeah. So let's say you're in such a control room. Yeah, for example in a power plant. Yeah, such as a Bakun, for example. Or in this case, we are talking about a control engineer sitting in a control room, monitoring the oil being pumped from offshore to onshore, for example. Yeah, and in this case, um, let's say one of the pump A, yeah, trip has trip, and from the monitor, the operator or the engineer not only know what is the cause of that. Yeah, but he has the option to switch to the other pump B. Yeah, so he can switch to the other pump from the control room there, from the monitor. He just touch the screen, and because A tripped, so he moved to B. But unfortunately, in this case, pump B also tripped, and also the cause also being unknown in this case. And then because of that, the alarms already went off. Yeah, and they don't know why the alarm went off in this case. Yeah, and in a few minutes, probably the controller or the control engineer heard an explosions and also so fire in this case. Yeah, and probably people get injured. Yeah, so in this case, there are 2 people killed, for example, and many more hurt. Yeah, at that particular time due to the explosions. Yeah, and fire. And probably this probably happened late at night. Yeah, in this case, at 10 o'clock at night, when most of the people already went back home with their family. Yeah. So probably most likely that this controller or this engineer probably in the control room alone. Yeah. He cannot talk to another engineer to get a second opinion maybe or to discuss the issue. Yeah. For example, in this case, for this particular offshore offshore to onshore pipeline, for example, talking about in Aberdeen, Scotland. Yeah, Aberdeen is really at north of Scotland, going towards Arctic, yeah? North Pole. Yeah, it's a North Sea. Basically, yeah? Um, and in it and the controller being being an engineer, so he's most likely the one in charge of this particular operations. Yeah, so he needs to make a decision in this case. Yeah. So you can imagine if you are at the offshore oil rig, something like this, yeah, probably 20 kilometer or even 50 kilometer from the shore, for example, yeah. So the only way to reach you, the fastest way probably by using helicopter, yeah. Um, and if you ship uh, or boat, maybe we're taking you half a day to reach you, yeah, from the shore, yeah. So as a as a person in charge, or in this case, normally they're working in shift, or they are the shift supervisor. What actually you can do? Yeah, so that's the question to be asked. What do you do in this case? Yeah. So things like this. Um, if you have a good um, control systems in place, yeah, probably that explosion will not occur. Yeah. And if you have a control system that can be ready for any accidents, yeah, because they already consider the risk involved, yeah, probably the control system will connect direct to the to the authority, right? Like in Malaysia, talking about bomba, for example, they come over, yeah. But in this case, they are offshore. They have to come up with their own policy on what to do if these things um, happen, yeah. So in this case, you need to have a very good control system. So what is the motivation why we need a good control system in this case? So one, to avoid the incident from occurred, and secondly, if it occurred, there must be a sequence on what to do to knock off the fire, yeah, to get rid of the fire. Yeah. So there are a lot of process or the incidents that occurred in the past 20 to 30 years. Yeah. For example, in 1988, for example, yeah, similar to the accident we just mentioned just now, yeah. In 1988 in Scotland, yeah, a company called Occidental Petroleum in Scotland, one of their oil platform called Piper Alpha, yeah, um, caught fire, yeah, and basically the offshore um, exploded, yeah, and many people killed. So I can say many engineers killed. In that particular instance, as many as 164 people killed in that incident. Yeah, and then they suffered a $2 billion loss. Yeah, due to that incident. Yeah? So this is how it looks like the aftermath of that incident or the Piper Alpha disaster in Scotland, and the one the oil rig um, in Scotland near to Aberdeen in this case. Yeah. Another example in 1984, earlier than the Papa Alpha disaster 1988, is also the Union Carbide plant in Bhopal, India, yeah, where the very poisonous gas called MIC gas being released into the atmosphere. Yeah, nothing to do with MIC Malaysia in this case, but this is the name of the gas, MIC. Yeah, so in this case, compared with the Piper Alpha disaster, where only 164 people killed in Piper Alpha disaster. For the Bhopal, India, as many as 3,000 to 10,000 people killed, yeah, and 100,000 people injured in this case. Although they reported that the losses uh, only half of those reported in Scotland, the Piper Alpha disaster, only between half to $1 billion uh, losses being reported. Yeah, so you can see the difference between developed country and a developing country. You know, when they are the value of human life, you can say that. Yeah. So that is the Papa India cluster. Yeah. So you can see these comparisons. Yeah. Um, in oil industry, big losses, monetary loss, although not many people killed. In a developing country where they have this kind of business coming into their place, yeah, dangerous. This Union Carbide actually belong to the American, yeah, so they set up their plant in India, yeah, so they know it's dangerous, so probably they did not get the approval to set up the plant in the United States. That's why they moved the plant to India, yeah, and then because of a well-known uh, danger of this particular plant. So when it's happened, the incidents happened. Yeah, many people killed. Probably they built the plant near the um, heavily populated area, for example. Yeah. Also, due to that, not just many people died, but also many people injured. Yeah, and yet the losses is small, although there are many people killed. If I mention back the Piper Alpha disaster, the Piper Alpha disaster also become um, because of the Piper Alpha disaster. Yeah, the procedures in oil and gas industry being improved due to that disasters. So now, if you had the opportunity in the future to visit any offshore rig, yeah, um, the 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 SOP or standard operating procedure, yeah, with regard to safety, etc., are very strict because they have learned from that experience when the Piper Alpha disaster in 1988. Yeah, so those oil rig run owned by multinational companies like Shell, Petronas, etc. Yeah, they have a very stringent rule regarding to the operation. Yeah, because they have learned from this disaster, the Piper Alpha disaster in 1988. There are many more other accidents. Yeah, for example, in Kuwait in June 2000. In this case, yeah, due to leakage, for example, that lead to flammable vapor being released and explosion occurred, and many people, as many as 7 people killed and many injured. And here they reported $400 million losses. Yeah. Then in 2001, in Brazil, the Brazilian national company Petrobras, yeah, in Malaysia we have Petronas, in Brazil we have Petrobras, yeah. They also experienced the offshore oil platform explosions. In this case, 10 people killed, and which incurred $5 billion in losses, and as a result, that particular oil rig sank into the Atlantic Oceans. Yeah. So when we're talking about Atlantic Ocean, talking about a depth of between 2 kilometer to 4 kilometer. Yeah. So 2,000 meter to 4,000 meter depth. Yeah. Which is very deep in this case. One is saying you cannot recover it back. Yeah. So if you follow the news, for example, Petronas just um, came with their oil platform, yeah, built by the Korean early this year, or if not end of last year, and that's one of the biggest of its kind in the world. Yeah, and they only operate at a sea depth of about 200 meter at the South China Sea. Yeah, so it's in comparison with the Atlantic Ocean, it's 10 times deeper. Yeah? Then in 2001, also in France, in Toulouse, France, the ammonium nitrate plant exploded. Yeah? So in this case, as many as 31 people killed and more than 2,000 injured. Yeah? So and many other and also many other minor accidents. Yeah, it's not mentioned about major, so the minor accidents. Yeah, as listed down here. Yeah, um, mostly deal with the chemical industry. This case. Yeah, mostly oil, um, mobile, Chevron, where BP, British Petroleum, BP, Conoco, yeah, all those oil and gas industry. Yeah, all in all, recorded up to 2001. There were 24 incidents with 12 deaths, hundreds hurt, with more than 1 billion US dollar losses, and the impact also due to the incidents of more than 10 billion dollar. Yeah. So now, what is the problems, the important and challenging in for a computer uh, control system designer? Yeah. One is it was reported that in the US alone, yeah, the incidents incurred up to 20 billion plus dollar on the economy, yeah, and half of it actually related to the petrochemical companies, yeah. So actually, these accidents, when talking about it, there are many accidents, so a billion here, a billion there, and then when you sum it up, it's really talking about a big money, yeah, a lot of money. Yeah? So in this case, the petrochemical companies have rated their number one problems, yeah, the accidents as accidents as their number one problems, yeah. So the money basically went to the drain in this case, yeah. So in this case, what we can say is that modern plants are more difficult to control, yeah, whether you agree or not. Why? Because the modern plant are typically more complex in configurations and very large, and they are in large scale. They're big in the size, and the running process at its limit reduces margin for error. And normally, this plant also will require plant-wide integrations. Therefore, if it's being integrated, the things integrated. And you have seen how we look at the dynamic system last Tuesday, yeah, by the transfer function, yeah. So become from many series or parallel in parallel become only one transfer function. So in that one big transfer function, there are many other small transfer functions in that one big transfer function. Yeah. So actually, it's make reasoning very difficult. Yeah. Especially if you did not program it. Yeah. So in this case, advanced control puts process in states which operators have difficulty managing in the event of an upset in the case of accidents. And they have fewer experienced operating personnel due to downsizing, yeah, especially like now, for example, when the oil price in the oil and gas industry, when the oil price went down, yeah. So what actually happened is that the companies start to retrench the staff, yeah. Normally they tend to retrench the junior one, and at the same time also they train the experienced one, yeah. So once the experienced one being retrenched, with few of them left, yeah. So when there are complex issue occur like this, quite difficult for the company to react to to address that kind of issue. Yeah. including the lack of adequate training of operators, for example. Yeah, after that. For example, if you look at Asia, for example, um, due to COVID-19 pandemics, yeah, they um, they retrench staff. Yeah. Then those who they retrench the most is actually the pilots. Yeah, they retrench as many as 70% of their pilots. Yeah. A bit scary in this case. I know you must be wondering how many experienced pilots left to fly all the aeroplanes. So they, you know, that Asia having as many as or they have more than 200 aeroplanes actually. So the typical um, read that one. Typical complaints from the operator. What are the typical complaints from the operator? One, inadequate precisions or temporal information. Yeah, or in other words, lack of true alarm order. Yeah, remember when we looked at the first um, example just now, when talking about pump A broken, then the operator switches pump B. And then when pump B also not working, straight away uh, explosions occurred. Yeah. So, or maybe in this case, he just try to figure out what to do next. Maybe. So they don't know what's the reasons why A broken, for example. They said to B. Maybe that by doing that actually that lead to the explosions, for example. Yeah. And there are excessive nuisance alarms due to weak conditional alarming capabilities. Yeah. So I know one of my pilot's friend, yeah, flying Asian Airlines from KL to London. Yeah. Last time they used to fly the Airbus 380, the double decker one, but now they are use 777. Yeah. So he told me, yeah, Captain Azim, yeah, his name is Captain Azim, my classmate. Yeah. In my form 5, he said to me that when they based on a autopilot, yeah, when the alarm set off, what they do normally they just reset it. That's what they do. Yeah. So imagine if the alarm is really leading to something serious, and then not much they can do. They just reset and keep on setting it. Probably the aeroplane probably cannot be controlled anymore. Yeah. So what happened to Boeing 737 737X the past 2 years? So they have to Boeing have to grounded the aeroplane and rectify the problems. Yeah. A few other Boeing 737X basically lost control while in flight due to erroneous reading. Yeah, so they grounded all the Boeing 737X, and then now they said they already rectified the problem, so they will allow 737 Boeing 737 to fly back again this year. Yeah, but this is actually uh, something to do with nuisance alarms due to weak conditional alarming capabilities as well as inadequate anticipations of process disturbances. Yeah. So in this case, a few of this Boeing 737X actually fell off from the sky. Yeah. Um, One of them actually the Lion Air flight in Indonesia. Yeah. And also one of them actually Ethiopian Airlines. After that, Boeing decided to ground all the Boeing 737X from operations. And it's also to do with lack of real-time root cause analysis, which leads to symptom-based alarming, and a lack of distinctions between instruments failures and true process deviation. Um, other other complaints, poor integrations of multiple information and control system components, and limited capabilities to view interrelated process data, lack of adequate tools to measure, track, and access past records of abnormal situations, as well as limited or time-consuming access to procedures or operating instructions, and cumbersome and unintegrated communications between and within plant units. So some of the issues that they mentioned or complaints from the operator in this case. Yeah. So really, we can say that this complaint actually require what's called the intelligent control. Yeah, we need intelligent control. Yeah? So in this industry 4.0 in the digital era, yeah, of the 21st century, I'm pretty sure that most of you have heard about um, artificial intelligence, for example. Yeah. Um, I first read the textbook on artificial intelligence in 2001. So there is more or less 20 years ago. Yeah. At the time when we read it, um, for us, it sounds like too futuristic. But 20 years after, from 2001, now it's 2020, artificial intelligence become something like of a norm. Yeah. Um, Try to send messages with WhatsApp, for example. If you happen to send the messages many times, yeah, WhatsApp will tell you you cannot send more than one person because this already sent many times, for example, to avoid people spread false news in this case. Yeah, that require in some way intelligent control. Yeah, do you agree? And then so now we go back to the actual things. What actually we mean with process safety and process control. So we're now going back to the 5 issues that we first discussed because the overview of our control system is now. With regards to process safety and process control, yeah. So it very much the primary concerns of the process industry. Yeah. So we need to increase the public awareness of potential risks, stricter legal requirements, and the increased complexity of modern industrial plants. Yeah. So from the accidents from Piper Alpha in Scotland just now, for example, the operations in a oil rig will become very strict nowadays. Yeah. And then overview of process safety. Yeah. In this case, the process safety is considered at various stages in the lifetime of a process. Yeah. So in this case, we need to look into the preliminary process design. So you need to consider preliminary process design. So basically, what you have done in your assignment for plot research, you're looking at the preliminary process design with regards to controlling of the power from the deriving energy or power from the turbine somewhere in the middle of the sea, yeah, offshore to onshore in this case, yeah. And then at the final state of the design, yeah, the design state hazard, and uh, we need to consider hazard and operability or hazard studies, yeah, and as well as a failure mode and fault tree analysis yeah, being used at the final stage of the design stage, yeah. And then the third, after the plant operations begins, these health studies will be conducted on a periodic basis in order to identify and eliminate potential hazards. Yeah? Examples of hazard studies, for example, we have come across. Yeah. For example, a plant want to do a modification in the existing design. Yeah. So in this case, the staff or that particular plant need to learn how to handle the new design. So in this case, they will call in the plant or we'll call in the consultant to come up with the heads-up study. Yeah. So the consultant will talk to the employee from top to bottom. Yeah. From the manager all the way to technician. Yeah. Um, Mechanics, etc. Yeah. Then they find out what is the best way to improve the process, in this case, the control process in this place. So that is the heads-up studies. Yeah? But modifications of, for example, the Petronas Methanol Labuan plant, for example, yeah, they have come up with improved design due to incidents in the plant a few years back, for example. Um, And the fourth one, the proposed plan or operating conditions changes will require formal approval. Yeah, and this considers the potential impact of the change on the safety, environment, and health of the workers and the nearby communities. Yeah. So in this case, it may require government approval. Um, in just for example, in the case of pharmaceuticals industry, for example, they're dealing a lot of chemical. Yeah, so they need to know how they discharge the wastewater, for example. Yeah, so in Malaysia, we might talk about the palm oil operations, for example. Yeah. After a serious accident or plant incidents, yeah, like the case of Hyper Alpha in Scotland just now, that will require a thorough review to be conducted to determine its cause and to assess responsibility. Yeah. So we need to know what caused that particular incident and whose responsibilities with that, so that we can improve on the SOP. Yeah. And even improve the hazard study as well. Yeah. So that normally in modern plants there will be multiple protection layers. Yeah. So in this case, the process safety relies on the principle of multiple protection layers. Yeah. Where each layer of protection consists of a grouping of equipment or human actions shown in the order of activation. This is the one. Typical layers of protections in a modern chemical plant. Yeah. So for that, for example, in the process design itself, then we had the basic control with regard to process alarms and operator supervision, followed with the critical alarms, operator supervisions, and manual intervention. And then we also had the automatic actions. And then we have physical protections. We have to relieve devices, yeah, for example, relieve air valve, for example, to release the trapped air so that it's not the pressure not built up in the system. Then we had the plant emergency response, this one here, yeah, and finally the community emergency response. Yeah, the top one actually that you can read is the community emergency response. Yeah, so here in case of chlorine gas leakage, for example. So the basic process control systems or BPCS is augmented with two levels of alarms and operator supervisions or interventions. So an alarm indicates that a measurement has exceeded its specified limits and may require operator actions. Then we also have the safety interlock system or SIS, which is also referred to as a safety instrumented system or an emergency shutdown ESD systems. Yeah. So for the SIS, the safety interlock system, a gas or vapor if over pressurizations occurs, yeah, where there are also probably place for combustibles, yeah, for fire to take place. Yeah. So in this case, we need many type of five type of alarm. The first type one, yeah, talking about the equipment status alarm, for example, when pump is on or off, or when the motor is running or stop. Then we have a type 2 alarm where they are abnormal measurement alarm. In this case, the measurement is outside of the specified limits. Yeah. And type 3 alarm, an alarm switch without with its on sensor. So when it is not necessary to know the actual value of the process variables or only whether it is above or below a specified limit. Then we may have type 4 alarm. In this case, type 4 alarm is an alarm switch with its own sensor, and this serves as a backup in the case the regular sensors fails. And finally, the type 5 alarm. which leads to automatic shutdown or start up system. Yeah. Okay, so there is many type of alarm. So some of you ask questions when you're trying to do your group assignment of lottery. So, for example, is it that the sensor they give you the measurements? Yeah, but there are many type of sensors, including alarm in this case. So, looking at the general block diagram for an alarm system, we have the instrument signals with the alarm activation, the alarm logic that will lead to the intermediate status as well as the final control elements in this case. Yeah. So this is an example of two floor alarm configuration. Yeah. So we look at type B first. Type C alarm system. We have independent sensors. We have the kit in here. Um, Measure the flow temperature, the flow control with the valve here, and then they give you the liquid out. Yeah. Whereas type 2 alarm system shared sensors. Yeah. Example here, they have liquid in the flow. Um, uh, the flow transmitter transmit the signals to the flow control, which control the valve opening. To get out in this case. Yeah. Or with two interlock configurations as given here, about the tank, storage tank, yeah, or the high pressure interlock as given here. Yeah. Example. So for the interlock system or the SIS, the SIS basically serves as an emergency backup system for the BPCS, and the CIS automatically starts when a critical process variable exceeds specified alarm limits that define the allowable operating region, yeah, or the starting or stopping a pump or shutting down a process unit. And normally only used as a last resort to prevent injury to people or equipment. And SIS, the interlock system, SIS must functions independently of the BPCS due to a malfunction or failure in BPCS, and thus therefore the SIS should be physically separated from the BPCS and have its own sensors and actuators. Yeah, so this is the real thing, you have to have it separated. Yeah. And the final thought on the control system design, on the overview of control system design, um, people say that the regulatory control system affects the size of your paycheck, but the safety control system affects whether or not you will be around to collect it, which is makes sense. Yeah. So that's the end of the lecture. Any questions? Yeah. So you have covered the lecture, covered the lecture on overview of control system design, although there will be a bit of interruptions along the way, but we managed to finish it. If no questions, then I'll see you next week on Tuesday. Okay. So if you haven't submitted your assignment, the group assignment of Lotus, try to do it by next week.